Hello students, welcome to this lecture, one area related to circles. So in this lecture, we will discuss exemplars problem, one areas related to circles. Okay, so let's get started. So in first number question, here we have if the sum of the areas of two circles with the radii R1 and R2 is equal to the area of the circle, area of a circle of radius R, then which option is correct? Okay, so how to find which option is correct? So let us see how to solve it. So according to the given condition, area of circle, this is equal to area of first circle plus area of second circle. Okay, so here area of first circle, here for finding the area of first circle, here the radius is R1 for first circle, so area is pi R1 square, and for second one area is pi R2 square, and the area of a circle with the radius R is pi R square. Okay, so therefore pi R square, this is equal to pi R1 square plus pi R2 square, and here pi is common in this equation, then we can cancel it out. So it implies capital R square, this is equal to capital R1 square plus capital R2 square. Okay, so here R square, this is equal to R1 square plus R2 square. So here the correct answer is option number B. Okay, and now let us move to next question. So in next question, here we have if the sum of the circumference of two circles with the radii R1 and R2 is equal to the circumference of a circle of radius R, then which option will correct? Okay, so let us solve this problem. So here basically according to the given condition, circumference of circle of radius R is actually 2 pi R. Circumference of first circle is 2 pi R1 and circumference of second circle is 2 pi R2. Okay, so according to the given condition, circumference of circle, this is equal to circumference of first circle plus circumference of second circle. Therefore 2 pi R, this is equal to 2 pi R1 plus 2 pi R2. Okay, and it implies capital R, this is equal to capital R1 plus capital R2. Okay, so here you can see in option number A, we have this condition R1 plus R2 is equal to R. Okay, so here the correct answer is option number A. So here correct answer is option number A. And now let us move to next question. So in next question, here we have if the circumference of a circle and the perimeter of a square are equal, then which option will correct? So let us see how to solve it. So according to the given condition, circumference of a circle, this is equal to perimeter of a square. Okay, so circumference of circle is basically 2 pi R, where R is the radius of the circle, and perimeter of square, that is 4 times side, that is 4 times A here. Okay, so side of the square is here A. So where R and A are the radius of the circle and side of the square respectively. And now if we put the value of pi, that is 22 by 7. Okay, so then it implies 22 by 7 times R, this is equal to 2 times A. And it implies 11 times R, this is equal to 7A. Okay, so 11R, this is equal to 7A. And it implies A is equal to 11 by 7 times R. And it implies R is equal to 7A by 11. Okay, so now area of circle A1, this is equal to pi R square and pi R square, and here R is 7A by 11. So if we put this, then we'll get pi times 7A by 11 whole square, that is equal to 22 by 7 into 49A square by 121. And if we now simplify it, then you will get this is equal to 14A square by 11. Okay, and area of the square, that is A2 is equal to A square. And now from equation number 2 and 3, so now from equation number 2 and 3, here from this equation, circumference of a circle is equal to perimeter of square. So here a1 is equal to 14 by 11 times a2. Okay, so 14 by 11 a2, so it implies a2 is actually greater than, sorry, a1 is greater than a2, so therefore a1 is greater than a2, hence area of circle is greater than area of the square. Okay, so area of circle is greater than area of the square. So here option number B, correct answer. So here option number B is correct answer. And now let us move to next question. So this is our question number 4. So it said to us, area of the largest triangle that can be inscribed in a semicircle of radius r units is what? Okay, so we need to find the area of the largest triangle that can be inscribed in a semicircle. So first of all, draw the diagram. Okay, draw the figure. So this is our semicircle. Okay, ACB, this is actually semicircle, and ACB, this is our triangle. Triangle. Okay, so from this figure, take a point C1, the circumference of the semicircle, and join it by the end points of diameter A and B. And here angle C, this is actually 90 degree. So angle C is here 90 degree. So triangle ABC, this is actually right angle triangle. So therefore area of largest triangle ABC, this is equal to half times height, that is AB times CD. Okay, so AB is base, so half times AB into CD. So here AB is 2R and CD is R. Okay, so now this is equal to 1 by 2 times 2R times R, that is equal to R square units. Okay, so by property of circle, angle in a semicircular right angle. Okay, so we get the largest triangle, the area of the largest triangle is equal to R square units. So here the option number A is correct answer. So here option number A is correct answer. And now let us move to next problem. So next question here we have, if the perimeter of a circle is equal to that of a square, then the ratio of the areas is what? Okay, so we have given if the perimeter of a circle, this is equal to that of a square. That means the perimeter of a circle is equal to perimeter of a square. Then the ratio of the areas is what? So we actually, this type of question we have discussed in our previous question here. Okay, so you can use this concept and you can actually easily find which option will be correct. Okay, so this question is for your homework problem. So this is your homework problem. And now let us move to next question. So in next question here we have, it is proposed to build a single circular park equal in area to the sum of areas of two circular parks of diameter 16 meter and 12 meter in a locality. Then the radius of the new park would be what? Okay, so in this question here we have this situation. It is proposed to build a single circular park equal in area to the sum areas of two circular parks, okay, of diameters 16 meter and 12 meters in a locality. Then we need to find the radius of the new park. Okay, so let us see how to find. So area of first circular park, whose diameter is 16 meter, that is actually pi times 16 by 2 whole square, that is equal to 64 pi meter square. Okay, and there, since radius r is diameter by 2, that is 16 by 2, this is equal to 8 meter. And area of second circular park, whose diameter is 12 meter, is pi times 12 by 2 whole square, that is equal to pi 6 square, that is equal to 36 pi meter square. Okay, since r, this is equal to the diameter by 2, that is equal to 12 by 2, and this is equal to 6 meter. So now according to the given condition, area of single circular part, this is equal to area of first circular part plus area of the second circular part. Okay, so if we let us consider r be the radius of the single circular part. Okay, then area of the single circular arc is pi r square. So pi r square, this is equal to 64 pi plus 36 pi, and it implies pi r square, this is equal to 100 pi, and it implies r square is equal to 100, and it implies r is equal to 10. Okay, so the radius of the single park, the radius of the new park would be 10 meter. Okay, so here the correct answer is option number A. And now let us move to next problem. So in next problem, here we have the area of the circle that can be inscribed in a square of side 6 centimeter. Okay, so here we have basically circle that can be inscribed in a square of side 6 centimeter, and we need to the area of the circle, okay, that can be inscribed in a square of side 6 centimeter. So let us solve this problem. So given side of square is 6 centimeter, and therefore diameter of a circle d, this is equal to side of square, that is equal to 6 centimeter. Okay, so you can draw this figure. So from this figure it can be observed that diameter of a circle d, this is actually equal to side of the square, that is 6 centimeter here. So therefore radius of a circle, this is equal to diameter by 2, that is 6 by 2, this is equal to 3 centimeter. And therefore area of circle is pi r square, and that is equal to pi times 3 square, that is 9 pi. Okay, so 9 pi centimeter square. So here the correct answer is option number D. Okay, so for this question the correct answer is option number D. And now let us move to next problem. So in next problem, here we have the area, we have basically a square that can be inscribed in a circle of radius 8 centimeter. Then area of the square is what? Okay, so let us find. So here given that radius of circle r, this is OC, is equal to 8 centimeter. So first of all you have to draw the figure. So here this square inscribed of circle. Okay, so that is inscribed in a circle of radius 8 centimeter. So radius of the circle is 8 centimeter. So r, that is OC, this is equal to 8 centimeter, and therefore diameter of the circle, that is AC. So AC, this is equal to 8 times 2, that is 16 centimeter, which is equal to the diagonal of a square. So it can be observed that this is equal to the diagonal of a square. And now let us consider side of the square be x. Okay, in right angle triangle ABC, here AC square, this is equal to AB square plus BC square. Okay, now by Pythagoras theorem we get this equation, AC square is equal to AB square plus BC square. So it implies 16 square, this is equal to x square plus x square, and it implies 256 is equal to 2 times x square, and it implies x square, this is equal to 128, and therefore area of square, this is equal to x square, and this is equal to 128 centimeter square. Okay, so area of this square is 128 centimeter square. So here the correct answer is option number B. And now let us move to next problem. So in next problem we have the radius of a circle whose circumference is equal to the sum of the circumference of two circles of diameters 36 centimeter and 20 centimeter. Okay, so we need to find the radius of the circle whose circumference is equal to the sum of the circumference of the two circles of diameter 36 centimeter and 20 centimeter. So let us solve this problem. So since circumference of the first circle is 2 pi r, that is actually equal to pi times d1, and this is equal to 36 pi centimeter. And here given d1, this is equal to 36 centimeter, and circumference of second circle, this is equal to pi times d2, that is equal to 20 pi centimeter. So according to the given condition, circumference of circle, this is equal to circumference of first circle plus circumference of second circle. Okay, so it implies pi times d, where d is a diameter of a circle. So here we say d is a diameter of a circle. So pi times d, this is equal to 36 pi plus 20 pi. and it implies D is equal to 56 centimeter. So the diameter of the circle is 56 centimeter. Okay, so therefore required radius of circle is basically equal to 56 by 2, that is 28 centimeter. Okay, so here the correct answer is option number C. And now let us move to next problem. So in next problem, here we have the diameter of a circle whose area is equal to the sum of the areas of two circles of radii 24 centimeter and 7 centimeter respectively. Okay, so let us solve this problem. So here first of all, let R1 this is equal to 24 centimeter and R2 this is equal to 7 centimeter, and therefore area of first circle is pi times R1 square, that is pi times 24 square, that is equal to 576 pi centimeter square, and the area of second circle, that is pi R2 square, and this is equal to pi times 7 square, and this is equal to 49 pi centimeter square. So according to the given condition, here area of circle this is equal to area of first circle plus area of second circle. So here the area of circle with the radius r is pi r square, and area of first circle is 576 pi, and area of second circle is 49 pi. Okay, so it implies r square this is equal to 625, and it implies r is equal to 25 centimeter. Okay, so therefore the diameter of a circle, that is 2 times r, this is equal to 2 times 25, that is equal to 50 centimeter. Okay, so the diameter of a circle whose area is equal to the sum of the areas of two circles of radii 24 centimeter and 7 centimeter is 50 centimeter. So here the correct answer is option number D. And now let us move to next portion. So here we will discuss very short answer type questions. Okay, so in here we have to write whether true or false, okay, and justify our answer. So in first question here we have, is the area of the circle inscribed in a square of side a centimeter pi a square centimeter square? Okay, so give reasons for your answer. So let us see. So let ABCD, this is actually be a square of a side A, and therefore diameter of circle this is actually side of square, this is equal to a centimeter, and radius of circle is a by 2. So now area of circle this is equal to pi times radius square, that is equal to pi times a square by 4. Okay, that is equal to pi times a square by 4. Hence the area of the circle is pi a square by 4 centimeter square. Okay, so we find the area of the circle inscribed in a square with side a centimeter is pi a square by 4. Okay, so the area of the circle is not not pi a square centimeter square. So this statement is false. So now let us move to next one. So in next one here we have, will it be true to say that the perimeter of a square circumscribing a circle of radius a centimeter is 8 centimeter? So give reason for your answer. So let us see the answer. So the given radius of circle r is a centimeter. Okay, so therefore diameter of circle d is equal to 2 times radius, that is equal to 2 times a centimeter, and therefore side of square this is equal to diameter of circle, and this is equal to 2a centimeter. Okay, so therefore perimeter of a square this is equal to 4 times side, that is equal to 4 times 2a, this is equal to 8a centimeter. Okay, so perimeter of a square is 8a centimeter. So yes, it will be true to say that the perimeter of a square circumscribing a circle of radius a centimeter is 8 centimeter. Okay, and now let us move to next problem. So in next problem here we have this figure. Okay, so in figure a square is inscribed in a circle of diameter d, and another square is circumscribing the circle. Okay, so now question is the area of outer square 4 times the area of the inner square. Okay, give reasons for your answers. So given diameter of circle is d, therefore diagonal of inner square is diameter of circle, that is d. Okay, so let side of the inner square EFGH be x. Okay, so EF for this square EFGH, here the side of the inner square be x we let here. Okay, so therefore in right angle triangle EFG, here by Pythagoras theorem, EG square is equal to EF square plus FG square, and it implies d square is equal to x square plus x square, and therefore d square is equal to x square, and it implies x square is equal to d square by 2. Okay, so but this side but side of the outer square ABC S is equal to diameter of circle, that is equal to d, and therefore area of outer square, this is equal to d square. Okay, hence the area of outer square is not equal to 4 times the area of the inner square. Okay, so therefore this statement is false. So in this figure we have this square inscribed in a circle of diameter d, and another square is circumscribing the circle. Now this is not true area of the outer square 4 times the area of the inner square. And now let us move to next problem. So in next one, here we have, is it true to say that area of segment of a circle is less than the area of the corresponding sector? Okay, so if it is true, then why? So let us see how to solve it. So it is true only in the case of minor segment. Okay, but in case of major segment area, this is not always greater than the area of the sector. Okay, so this statement, this is not true to say that area of the segment of a circle is less than the area of its corresponding sector. This is only true when we have a minor segment. Okay, so for case of minor segment, that this is true only. Okay, so now let us move to next problem. So in next one, here we have, so is it true that the distance traveled by circular wheel of diameter d centimeter in one revolution is 2 pi d centimeter? Okay, and why? So here this is false, because the distance traveled by the wheel in one revolution is equal to its circumference, and circumference, that is actually pi d, that is 2 pi r. Actually circumference of the wheel was, since d's diameter is equal to 2 times r. Okay, so this statement is not true. So it is not true that the distance traveled by a circular wheel of diameter d centimeter in one revolution is 2 pi d centimeter. Now let us move to question number 6. So in question number 6, here we have, in covering a distance s meter, a circular wheel of radius r meter makes s divided by 2 pi r revolution. So is this statement true, and why? So here this is true. The distance covered in one revolution is 2 pi r. Okay, so in covering a distance s meter, a circular wheel of radius r meter makes s by 2 pi r revolution. Okay, and now let us move to next problem. So in next problem, here we have the numerical value of the area of a circle is greater than the numerical value of its circumference. Is this statement true, and why? So this statement is basically false. Why? Because if 0 less than r less than 2, then numerical value of circumference is greater than numerical value of area of circle, and if r is greater than 2, then area is greater than the circumference. Okay, so that is why this statement is false. And now let us move to next problem. So in next one, here we have, if the length of an arc of a circle of radius r is equal to that of an arc of a circle of radius 2r, then the angle of the corresponding sector of the first circle is double the angle of the corresponding sector of the other circle. So is this statement false, and why? So first of all, let two circles C1 and C2 of radius R and 2R with centers O and O dash respectively. So it is given that the arc length AB of C1, this is equal to arc length of CD of C2. Okay, that is AB, this is equal to CD, this is equal to L. This is said. Okay, so now let theta 1 be the angle subtended by arc AB of theta 2 be the angle subtended by arc CD. Okay, at the center. So AB, this is equal to L. Arc length AB is L, that is Q1 by 360 into 2 pi r, and CD is equal to L, this is equal to theta 2 by 360 into 2 pi into 2r, that is equal to theta 2 by 360 into 4 pi r. So now from these two equations, it implies theta 1 by 360 into 2 pi r, this is equal to theta 2 by 360 into 4 pi r. So it implies theta 1, this is equal to theta 2. Okay, so that is angle of the corresponding sector of C1 is double the angle of the corresponding sector of C2. Okay, so the given statement is true. Okay, so that it is true statement. And now let us move to next problem. So in next problem, here we have the area of the two sectors of two different circles with equal corresponding arc length are equal. Is this statement true, and why? So this statement is basically false statement. So actually it is true for arcs of the same circle, but in different circle it is not possible. Okay, so now let us move to next problem. So in this problem, here we have the areas of two sectors of two different circles are equal. Is it necessary that their corresponding arc length are equal? Okay, and give reasons why. So this is not true. Okay, the statement given to us is false basically. So it is true for arcs of the same circle, but in different circle it is not possible. Okay, and now let us move to question number 11. So in question number 11, here we have asked, is the area of the larger circle that can be drawn inside a circle of length c meter and breadth b centimeter. Okay, so when a greater than b, so a centimeter and breadth b centimeter, so length is a centimeter and breadth is b centimeter. So the area of the larger circle that can be drawn inside a rectangle is pi times b square by 2 centimeter, where b by 2 is the radius of the circle, and it is possible when rectangle becomes a square. Okay, so this given statement is actually false. Okay, so this statement is false. Now let us move to next problem. So circumference of two circles are equal. Is it necessary that their areas be equal? So, and why? So if circumference of two circles are equal, then their corresponding radii are equal. Okay, so their areas will be also equal. Okay, so the statement is true. And now let us move to question number 13. So it said to us, areas of two circles are equal. Is it necessary that their circumference are equal? So this is, if areas of two circles are equal, then their corresponding radii are equal. Therefore, so their circumference will be equal. Okay, so the statement is also true. And now, is it true to say that area of a square inscribed in a circle of diameter p centimeter is p square centimeter square? Okay, so here when the square is inscribed in the circle, the diameter of the circle is basically equal to the diagonal of the square, but not the side of the square. So this statement, the given statement is true. Okay, the given statement is true. So I stop here this lecture. Thank you very much to all of you.